Hi, I am Revathi. I am working as Assistant Professor in SNS College of Engineering in Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic about data flow. Devices can communicate with each other by sending and receiving data. The data can flow between the two devices in the following ways: simplex, half duplex, full duplex. There are three ways devices can communicate with each other. Simplex. In simplex, communication is unidirectional. Only one of the devices sends the data and the other one only receives the data. Example, in this diagram, from one computer is sending data to other computer. Data travels only in one direction. Half duplex. In half duplex, both the stations can transmit as well as receive, but not at the same time. When one device is sending, other can only receive, and vice versa. For example, walkie-talkie. Full duplex. In full duplex mode, both stations can transmit and receive at the same time. Example, mobile phones. A network is a two or more devices connected through a link. A link is a communication pathway that transfer data from one device to another. Devices can be a computer, printer, or any other device that is capable to send and receive data. For communication purpose, two devices must be connected in some way to the same link at the same time. There are two possible types of connections, that is point-to-point connection and multi-point connection. A point-to-point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. Most point-to-point connection use an actual length of wire or cable to connect the two ends, but other options such as microwave or satellite links are also possible. Point-to-point network topology is considered to be one of the easiest and most conventional networks topologies. Advantages of point-to-point connection: high bandwidth, security. Point-to-point connections are more secure than multi-point connections because the link is dedicated to only two devices. There is no risk of other devices can communicate and eavesdrop these systems. Reliability. Because a point-to-point connection provides a dedicated link between two devices, it is usually more reliable than a shared link. If there is a problem with the link, it is easier to troubleshoot and fix because there are only two devices involved. Reduced latency. Point-to-point connections offer lower latency than multi-point connections because there is no contention for the link. This means the data can be transmitted more quickly, which is especially important for real-time applications such as video conferencing or online gaming. Increased control and improved performance. Then it is used for distance also. This is cost effective and easy to manage. Multi-point connection. It is also called multi-drop configuration. This connection, two or more devices share a single link. If more than two devices share the link, then the channel is considered a shared channel. With shared capacity, there can be two possibilities in multi-point line configuration: spatial sharing, temporal sharing. If several devices can share the link simultaneously, it is called spatially shared line configuration. Temporal sharing or time sharing. If users must take turns using the link, then it's called temporarily shared or time shared line configuration. Advantages of multi-point connection. Cost effective. Multi-point connections are usually less expensive than point-to-point connections because they allow multiple devices to share the same resources such as cables, routers, and switches. Scalability. Multi-point connections are more scalable than point-to-point connections because they allow multiple devices to be connected to the same link. This makes them suitable for large networks that require many devices to be connected. Flexibility. Multi-point connections are more flexible than point-to-point connections because they allow multiple devices to communicate with each other over the same link. This makes them suitable for applications that require collaboration or coordination between multiple devices. Increased efficiency. Multi-point connections can improve network efficiency by allowing multiple devices to transmit data simultaneously. This reduces the chances of network congestion and improve overall network performance. Simplified management. Multi-point connections simplify network management by reducing the number of physical connections that need to be managed. This reduces the complexity of network administration and makes it easier to troubleshoot problems. Enhanced collaboration, improved reliability, and then greater access, improved security. Improved security. Multi-point connections can improve network security by allowing for centralized monitoring and control of network traffic. This make it easier to detect and prevent security threats such as unauthorized access of or data breaches. Thank you.